All right, I think we are live. A little bit of a delay here. Again, I'm on YouTube. Go ahead and subscribe now. I usually post this later on Facebook, but if you want in on the live feed, this is right around, what time is it? It is 7:40 in the evening here Thursday night. I want to go over the latest guidance here. We're specifically talking about North Alabama and parts of Middle Tennessee with this. And there are some changes to the forecast guidance. One of the models, the HRRR, is really increasing the threat for damaging winds and embedded tornadoes, while the graph model, the one that performed so well last Friday night, does have some supercell potential activity developing ahead of it tomorrow evening, and then the main line coming in. It's a little bit later by 2 or 3 hours still. So let's get into it. I want to show you what's going on here. This is the threat. It develops tomorrow morning. And right now they have a few thunderstorms in progress out there in Oklahoma, but really nothing severe, just very heavy rain, and that's moving into Missouri. But as we continue on here, what's going to happen is this area is going to move to the east with time. What we're going to be watching ahead of this main line, and the reason I've got this area in white is this is the area I think is going to be the maximum threat for damaging straight line winds due to what we call this 850 millibar low-level jet stream. Most likely area to see a prolonged event, kind of like we had here in North Alabama last Friday, but shifted a little farther to the north. What I'm watching for is to see what's going to happen in this area here, because if we get supercell storms to develop, of course, they're going to race northeast at about 60 to 70 miles per hour, so we will have to watch that. So again, the window's kind of closing in. We're about 24 hours from this event. I do want to focus here on this low-level jet stream and what that entails. This low-level jet stream is very important in seeing these streaks, what we call them, these gusts of wind in this low-level jet. Now, these winds you see here, they're about 4,000 to 5,000 feet above the ground. The thing is they drive a lot that's going on here on Earth. Our winds are going to be gusting 35, maybe 40 miles an hour ahead of this line of storms. What happens is sometimes these winds, they get forced down by the heavy rainfall. And you're going to see here, this is the graph model. I'm going to show you the HRRR model as well coming up here in just a second. But what that's going to show is a little bit more of just one line. What we're looking at here as we go towards 7 o'clock, and by that time I'm going to just briefly go up here into Middle Tennessee. This is what we're kind of looking at, these little areas in blue. Those are those little jet streaks coming through in the model data, and this is probably a little later than some of the other guidance, but this just kind of shows you the environment of the atmosphere. Whenever something like this comes through, what we'll see is that gust of wind down to the ground, and perhaps even like a lot of what happened in Florence last weekend in northwest Alabama was, I believe it was more of a mesocyclone that was actually just on the ground, a non-descending tornado, and then of course it did some tornado damage. But that's a classic example of what these kind of storms can do. They come in and they do tornado-like damage with winds at 70 to 80 miles per hour. Are the further models of the graph still showing the lower level jet picking up in the early morning? It doesn't really look like the early morning hours. It's going to be the evening, as you see here. Again, that's one comment there. Thank you for the comment. But what we're looking at is all of this is going to be just off to our northwest. Now watch what happens here with the graph model. This area here, this is one of these jet streaks out ahead of this main line that's likely going to be in this area here at the time. So as we go forward, look what happens there. This is very concerning as we go through time, if this were to happen. And notice the intensity of this over Russellville. So this is the representation by the forecast model of a supercell storm with the potential to produce a strong long track tornado. And I want to stress, it's model data. It's not exactly what's going to happen, but this model was pretty darn accurate last weekend. What it does here is it takes this long track and moves it through Limestone and into Madison County. So I'll show you as we go forward in time. And also notice the development that's happening back here up into Mississippi with the main line. So as we continue on, notice it's still there, although it's not as strong, it's still there. And what we've really learned from that last weekend, last Friday, was and for other meteorologists out there, you really need to focus on these long track storms entering your area, because even though it may not be producing a tornado, that circulation, all that energy is still built in with that storm, and it takes a while to get rid of all of it. And we had widespread wind damage from the storm that moved through Mississippi that was a long track tornado at one time. It did produce a tornado. In fact, just today they came out with a Falkville tornado. I think it was 132 miles an hour, EF2. So those are really strong EF2 tornadoes there. So again, this graph, we're going to go over the HRRR model here in a second, but the graph model then along this line near Corinth and Hohenwald, just west of Lawrenceburg, what this would be doing would be producing these line echo wave pattern embedded tornadoes and very strong winds, with the individual storms within that moving likely at about 70 miles per hour, maybe 60 to 70. They're going to be moving pretty quick. So as we continue on here, notice as we go towards just past midnight, and this has been very consistent. So I'm really concerned, especially with parts of Middle Tennessee, southern Middle Tennessee, of a significant high impact wind event with embedded tornadoes. As we continue on, you can see Shelbyville, even up towards Fayetteville, and you guys had that tornado. It formed a little differently. It was a bookend vortex, but it had a consistent rotation, and that was the same storm actually that moved through Florence. So as we continue on past about 2 o'clock in the morning, we'll continue to see some of that. Now I'm going to get into more data as far as the future radar data. All this should be out of here fairly, I'd say 4:30, 5 o'clock in the morning. Here's the HRRR. You're going to see something a little different in here. What I'm plotting is CAPE. That's convective available potential energy. That's that big blob of red coming in. And that's the other thing. Those really strong winds are bringing in this really unstable air, and it basically brings everything together all at the same time. So even though we don't start out with a very unstable atmosphere, we may have some elevated thunderstorms here in North Alabama, southern Middle Tennessee, northeast Mississippi, with some small hail late tomorrow morning into the early afternoon hours. That really won't be severe. There's no instability out there, at least it's surface-based. And that's the critical part about this area in red. It's the surface-based thunderstorms here. So overall, let me turn this back. It is on. Okay, I kind of got lost up there in what else is going on my screen. Again, I'm sharing the computer at work. So this is where it starts to get muggy. After 3 o'clock over northwest Alabama, and you're going to start to see something else showing up here, and these are going to be helicity tracks. And this is really important too. This showed up a lot last Friday, and all along those helicity tracks, we had significant wind damage. So by 5 o'clock, we're looking at an unstable air mass in Florence and in Russellville that would support severe storms. And as we continue on, notice the fine line here, nothing going on farther east. Oh, got a phone call. It's my brother. I'll have to call him back. But what this also looks, the potential we'll have to watch out for is if this instability doesn't get all the way over to Fort Payne or Boaz or Albertville, this line is going to have momentum built up, and it's going to run into the more stable air, and that can create what we call a wake low. And this would be a fairly significant wake low if that were to happen. That means basically the air is like running into a seawall, a wave on the lake, and it just keeps rocking back and forth, and low pressure developing behind it as well. So as we continue on here, as we get past 840 or so, and I want you to remember 840, because we're going to go to the graph model, and that's when the graph model starts to spin up that supercell out here. Again, I show you this because this model doesn't show it, the other model does. So the models are still not all in agreement, but what is in agreement is they're kind of ramping up the instability leading up to this. So a slight drop here with the number there, but that's still plenty enough to support. And when you get this close, if you get a line that has this much wind shear in it, you're going to have problems. Notice that the thing that's happening here is this model, the HRRR, has something kind of in the same area at a different time. It's not quite tightly clustered like you'll see here coming up. But also notice as we go, these little blue streaks here, these are helicity tracks. And these helicity tracks are really important. And again, the model guidance is here to guide us. It's here so when I'm on the air and if I'm in continuous coverage tomorrow, I can remember where was the model putting it and what time, And if we have a storm that's doing that, I'm like, this will likely continue. It's also important to notice it gives you the setup of the atmosphere. It doesn't mean it's exactly going to be where you see it here, but this is a significant threat. Notice what happens there as we see that. We see these helicity tracks all the way through Lawrence County, through Moulton, even up here in northern Madison County, south of Ardmore, and then another area back here southwest of Russellville. And also notice how in Boaz, the instability has climbed to about 500 joules per kilogram there. And this is 2 o'clock in the morning, so this is another overnight storm system. And notice it kind of moves out around 4 to 4:30. So now I'm going to switch gears here, and this is going to be the graph model. Notice the change here. We've got this supercell it's trying to form right here, northeast of Tupelo. And from there, it goes pretty much east-northeast. It's following the wind. And the other thing I've got on here, I'm still plotting the graph model, the HRRR model, I should say. I'm still plotting those helicity tracks just to kind of see where they reference on this particular model here. So as we go through time, 11:30, notice this shows more instability. This shows a lot more instability, this graph model does. And it kind of gets messy here between 1 and 2 o'clock in the morning, but still very high instability. Notice this is quite a bit higher than what the HRRR is showing. And this line here coming in, it's got it 3 o'clock in the morning instead of about 1:30 or 2. So both of these models are kind of, and the difference between these models, the HRRR and the graph model, they're high resolution models. They update about every 3 hours, whereas when we start forecasting for severe weather, we begin with like the European model and the GFS. They're really not much value to us right now because they run every 12 hours and their resolution's not as good because they're dealing with several days out versus a few hours out. And that's why these models become critical. Notice the setup. Again, this is also important just to look at what the HRRR does. It has the line of storms at 3 o'clock in the morning already down here with all this wind shear. So we're still likely dealing with this kind of helicity track along this line here. And the later it arrives, the more instability there is for it to work with. So somewhere in between both of these model solutions is probably the correct answer. But as we continue on here, this is 4 o'clock in the morning. It still has these thunderstorms here. And notice the Cape and Boaz, Gunnersville, 1,260 joules per kilogram. So we really have to watch that. Notice it also throws out what appears to be another supercell here, Albertville, just south of Douglas, south of Fort Payne and Boaz. So going to have to watch that. Doesn't mean that's exactly what's going to happen, but that's what we're basically trying to prepare you for when we give you that forecast as we go through time. And overall, here's another thing I really like to look at. This is called the Energy Helicity Index. Anything above 1 is supported for tornadoes. What this product does is it takes all that instability and then it overlays with that in the algorithm the amount of wind shear we have too. So it gives you a fairly good example of what the atmosphere is capable of. And you get into the pink here, and that's about 3. So 3 is pretty supercharged atmosphere. And notice this right here at 8 o'clock, it's got a 2.4 in Tupelo, a 3 in Florence. And this may actually be a new run here by the graph model. It's got the same thing, but just a little farther to the north. And as we continue on, what I'm plotting here is the graph precip and the HRRR EHI. So this gives you, again, this setup here. Overall, the storm system's still evolving out west. And as we take a look here, right now we basically, you see that area blue in the Ozarks, that's basically just a big mass of thunderstorms going on right now up there in southwest Missouri. Very noisy, but that's kind of the leading edge of this very strong wind that is starting to come through. So again, I'm going to end this. Let me see, I got a few questions here. How's it trending as far as the time in the last update? The timing is, I would say the HRRR has slowed down about an hour, and the graph model has sped up about an hour. So they're both kind of coming to that solution here. Yeah, I like doing the YouTube because you can actually watch it on television and you can pull up on the big screen. You can kind of watch it whenever you want. You know, Facebook Live's kind of limited as to you've got to be right there. And again, I like having the big screen too. Appreciate you guys watching. Appreciate the comments. I'll be doing more of this stuff over time. I finally got everything set up, and hopefully eventually I'll have a big garage I'll be doing this with, kind of a studio production with Mustangs in the background kind of thing. And again, all with time. It's a slow process. Again, appreciate you guys. If you guys don't mind subscribing, you'll get more updates and you'll know when I'm on here. Appreciate it. You guys have a good one.